Okay, so then it's 9 o'clock. So let's let's start. So welcome to the 8th virtual winter symposium of the Human Motion project. So the title is actually a question: Human motion in times of Corona, a booster for walking, the use of wearables in clinical trials and telemedicine in clinical practice. Now, should we get into technical problems and the meeting should stop in a couple of minutes, I could give you the answer. The answer is yes, if we take the right steps. Now there is the question about the person that is in the logo, which is a vulnerable human being, and this being is somehow is surrounded by circles and squares, and that somehow shows what was the topic of this symposium. Human motion seems to be the most powerful treatment option for the pandemic in the last year or so. So by restricting the motion of humans, probably millions of lives have been saved because, the virus only can spread if people transmit it. The problem is that restricting human motion causes severe side effects. And at the moment, we only have a vague idea what kind of side effects these are for mind and also for the physiology, loss of muscles and so on. And we will have lots of talks discussing this. Now, I will have a couple of overarching points. One has to do with the funding of this symposium. So here we have a statement saying that we do this for free, but of course we are happy to get donations for these activities. And the nice thing is that the first donation we received the day before yesterday actually came from a former student. And so we've seen many other organizations and strong academic institutions being involved. So we'd be really glad to get some funding through donations if possible. There is one support I'd like to highlight. This is the ZIM, Zentrales Innovationsprogramm Mittelstand, which is a funding program of the German Ministry for Economic Affairs. And they fund one project. And let me briefly show this. This is a project about scoliosis. And it's one of the milestones of the project to actually present this at the symposium here very briefly. So scoliosis is a typical example of what we're facing here. So it's a special curvature in the spine of typically young women or young girls. And the usual way to treat this is actually take a brace, which is a brute force way to try to get this straight. And the problem is by doing this, you may do more harm than good, and muscles will go away. And so there are ideas to now either replace the wearing time of the brace by doing sports and exercise. On the other hand, there is a novel idea from a group we're collaborating with. It's called taping shirt. And so that you are wearing something like an underwear with certain tapes that somehow try to stimulate the body in order to be more upright. Now, our role is going to be use sensors technology to measure the wearing time of the brace, measure the wearing time of these more modern tools, and on the other hand, also measure the activity and the exercise the young woman would be doing, or the patient will be doing, and then have a smartphone app that somehow gives decision support and motivation to the wearer. Okay, now in this picture, well, if we go back to the picture, so what we're doing here and what we will be discussing today is a little bit like trying to square the circle to get the balance right between restricting human motion and allowing human motion and do exercise and to find the right balance. And now squaring the circle from a physicist's point of view is very briefly described in this beautiful painting here that I've produced yesterday. So a physicist would argue like this. If you want to square the circle, in other words, if you have a circle here and you want to calculate the area, the first thing is you realize, well, this is a two-dimensional topic, so the area is going to scale with r squared with some constant. And then the question is, well, what is this constant? Well, one part is that you see immediately, if this is just 1, then it's definitely smaller than 4 because we've got these 4 squares. And we also see there's another square, and this has this length, and we know all from Pythagoras, this is square root of 2. So the other square has just an area of 2. And so a good estimate is, well, take the mean, and this is 3. So a physicist's rough estimate would be, well, the area of a circle is 3 times r squared, which is a very pragmatic and powerful way to move forward without getting into too many details. And this is also, I think, important in this pandemic to somehow get the scale right and get the rough estimate right. But it's not needed to have everything nailed down to the absolute precision, a typical German problem somehow. Now, there are some interesting aspects here. So one is the exact number, and we all know this exact number is not 3, it's pi, it's 3.141. And so this number in comparison to this other number, square root of 2, which is irrational, but still can be defined by a polynomial, x squared minus 2 equals 0. That's defines square root of 2, which can be easily constructed. But pi is harder, and people call it transcendent or transcendent. That means there is no polynomial like this where p of pi would be 0. And the proof, I've checked this, that this is the case, was done in 1882 by a German mathematician who was there at that time in Freiburg, then later on at the LMU in Munich. And if I understand correctly, in this proof, he used Euler's formula, e to the I pi plus 1 equals 0. E to the I phi would just be this arrow of length 1 that is somehow rotating as phi is changing. And it was known that E is actually a transcendental number. And the idea is if e to the I pi plus 1 equals 0, then somehow pi also has to have this special feature because I and 0 and 1 are too simple somehow. Now, it was on purpose that it's a bit ugly, this picture, because it shows, and that's what I've learned from my teachers in mathematics, that even bad handwriting cannot destroy the beauty of mathematics. And this formula, e to the I pi plus 1 equals 0, is supposed to be the most beautiful and powerful and nice formula in mathematics. So Richard Feynman, for example, had this impression. And in a similar way, e to the I pi plus 1 equals 0 could be written for quantum mechanics as psi t, which is a vector in a Hilbert space, is e to the minus I h t psi 0, which is the evolution, time evolution of the wave function, which is somehow the rotation of a vector in an infinite dimensional space that doesn't change its length. Okay, now this formula, which is differently written like this, that's what I've done for many years in my life with a teacher, Daumer, who was somehow proposing a theory that's called Bohmian mechanics, which is a combination of the usual way to do quantum mechanics, namely Schrödinger's equation, supported by a so-called guiding equation, where you have point particles in motion, and here you have some trajectories of these point particles in a double slit experiment. So that's an absolute no-go in the usual interpretation, Copenhagen interpretation of quantum mechanics. And this is a beautiful mathematical theory that is at the core of quantum mechanics and also of all the modern technologies like MRI, as we will see later in a talk. Now, some of you may know this. We have dedicated this symposium to the memory of Daumer, who has died in January due to Corona. So this is the group of the many students and professors and postdocs he has been educated. I was together with Karin Berndl, his first PhD student here in Munich. And he died at the age of 69 due to corona, which is a big loss. So he liked Lewis Carroll, and here we have Alice asked, would you tell me please which way I ought to go from here? And well, the cat says, that depends a good deal on where you want to get to. And so that's, I think, an interesting frame also for this conference. Well, if we walk, we need to walk in order to move forward, and we should have an idea in what direction we should go. And that somehow would be the element where I would now try to at least start to see whether our keynote speaker, who talks about the praise of walking and the impact it has on mind and body, is available.